See, we have to understand how the viscosity is coming into picture, because we already know that meaning of viscosity, that is called resistance or restriction, right? So it's kind of a motion of one lamina is restricted by another lamina, right? Now first you should understand what is lamina in this. So in demo class I was explained to many students, and it was like, when a flow is happening, then we assume that the fluid travels in the form of lamina, right? It's kind of blanket, one blanket over another blanket, one blanket over another blanket, right? So one blanket, another blanket, another blanket. You can also say layer, lamina is the technical name, layer is very common name, layer, lamina, right? Now see, suppose one layer is flowing, one layer is flowing, one layer is flowing. So they will not be having same speed. Why? Because the ground layer, or you can say the ground lamina, will be stationary, because molecules of the ground lamina will be in the contact of the earth, right? The bed of the ocean, or you can say bed of the river. So these molecules will get stuck here in these spaces. So this bottom lamina will not even move. Then lamina just next to this, that will be having molecules. So those molecules will be under the attraction force. So this lamina will slow down. So now this lamina, next lamina, will again be having attraction force with these molecules. It means what? These molecules are offering resistance to each other, which is which is the cause responsible for resistance in the motion. So this is how this liquid feels difficult to flow. If these molecules are not attracting each other, then it will flow easily. But because they're attracting each other, so that's why they are not flowing easily. So this is one reason which is generating viscosity in any liquid. We have one more reason. Now for that I have taken one loose example. This is not the real example, but just for the feeling purpose I am giving this example. Suppose these are cars. Car. They are moving in this direction. Suddenly one car started going in this direction. So what will happen? This line will slow down. And suddenly this car started moving in this direction. So what will happen? This line will slow down. Correct? So you know what is this called? This phenomena. Now imagine this total thing is one layer, one lamina. This total thing is one layer, one lamina. This is one lamina. What I explained here, same thing. Now this is called mass transfer, or you can also say momentum transfer, right? So this is one more way that you know that molecules are not stationary. They can go in any random way. So this motion is also causing a disturbance to the flow. So this is another way which can produce resistance in the liquid, right? Which can produce viscosity in the liquid. Now see, we should understand how viscosity of the liquid and the gas being affected at molecular level, not mathematically, definitely mathematically also, but at molecular level also we should understand this.